Okay, let's start our second talk. So we would like to invite Professor Valmir Freitas. Professor Valmir Freitas earned his PhD degree in electrical engineering from the University of Campinas, Brazil in 2001, where currently he is a professor. In the last 15 years, he has participated as a principal investigator in more than 30 R&D projects for Brazilian and Canadian utilities and government agencies, published more than 50 journal papers, and supervised more than 30 PhD and master students. He is an editor of the IEEE Transactions on Power Delivery and the IEEE Power Engineering Letters, and chair of the IEEE Working Group on Power Quality Data Analytics. His main research interests are distribution system, distributed generation, power quality, and protection. Thank you once more.
I don't use a cell phone, so I have a watch here, okay? You see I'm a strange guy, okay? First, I'd like to thank for the invitation. It's a pleasure to be here and share some of the work we have been doing in Unicamp. I'd like to give a special thank to Professor Felipe, Professor Kleber for the invitation, and Bruno. Where is Bruno? Bruno makes everything works very fine for me, at least, okay? So the idea is, my presentation is not so technical. What I'm going to show you is a series of projects we are doing with CPFL. And this project started maybe 3 or 4 years ago, and they are still going on. And the idea is to have a living laboratory to investigate the impact of emerging technology into the distribution system. So basically, it's a picture of different projects, okay? Very, very not technical. I have to put that because I put the name CPFL, okay? Everything I say here, I'm the only guilt guy, okay? During my presentation, I'm going to show a few numbers from Unicamp because some people here are not from Brazil, a few numbers from CPFL Energy, the utility we have been working with. Then, a definition about what is Living Lab is not my definition. You can find many different definitions in the internet. I just took one from the European Living Lab definition. Then I'm going to talk what I'm calling emerging technology into distribution system. And then I'm going to talk about the projects, what we have been doing there. Okay? I'm not going to spend too much time on this next slide. If you're not from Brazil, the important thing to know, Unicamp is a real research-based university. Okay, you can see that by taking into consideration the number of undergrad and grad students. The relationship is almost one-to-one. Okay, we are second patent leader in Brazil and blah, 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 and so on. Of course, there's a catch here. This is from 2015. If I change for 2016 or 17, the numbers are a little bit worse than that. But I prefer, okay, I'm lazy, I cannot update the numbers and stay with the good numbers, okay? We have good position in Latin America and so on. One important thing we like, we have too many, no. We have a few spin-off companies, okay? That's quite important at Unicamp. So patent is important, to have a spin-off company is important, and so on. Okay, this is to say, oh, it's good, blah, blah, blah. Though, CPFL. CPFL Energy is used to be a Brazilian utility. Now you can see here, it's kind of Chinese utility, né? State Grid is the owner, the CPFL. But the main point here is to show they have 5 different distribution utilities. Okay? This is the main business from CPFL. But they also have service company, commercialization, generation. Here is most is hydro. And they have some renewable, solar, wind, and so on. Another important thing is that slide. That how much money they spend per year on R&D. You can see it's around $10 million per year, something like that. For the last 3 years, the amount is something around $10 million per year on R&D. If you're not from Brazil, in Brazil we have an official R&D program. the utilities have to spend some money on R&D. And this is the kind of money the CPFL group spend on R&D, okay? And we use part of this money to start to build this living lab. That's the idea here. And you can see most of the projects are related to distribution because distribution is the main business from CPFL. Okay, what's a living lab? If you go over the internet, you are going to find many different definitions, like smart grid or any definition you look on the internet, you're going to find many different. But in my opinion, what is important in a living lab is that user-centered, okay? Real-life communities, citizen, active user involvement. I used to say, living lab is, I'm checking, testing, developing some technology, but I have to reach the final user. Okay? So in my opinion, it's nice to start a living lab inside a university, but you have to go outside the university. Because the way people inside the university interact with technology is quite different from people outside the university. So for me, it's important to go outside the university. You see, most of our projects are outside the Unicamp. Okay? And what I'm calling emerging, because they are not that new, okay? Emerging technologies. What is changing in the distribution system? You can say distributed generation, PV, okay? Distributed sensor meters, and in my opinion, it is, if you take the world, it is well-established market right now. We have, you can use a few numbers, for example, in USA, you have more than 6 million smart meters right now. So maybe some of this technology are not so popular in Brazil yet, but if you take consideration the world, these are mature technology right now. So PV, smart meter. The other one, in my opinion, is not that developed yet, okay, is the electrical vehicles. But of course, this will be the next step, because most of the manufacturers, they want that. But of course, you are not going to take all the vehicles in the street, put this on the trash and change for electric vehicles. So you take time to have a lot of electric vehicles on the street. Then the next two ones, in my opinion, is the future. Okay, it's not. Maybe for some application they are already okay, but not for most of the application. Is the energy storage system. And here I put battery because I'm talking about distribution system. In distribution system, probably battery is the best solution because of the size and blah, blah, blah. And I think this will improve a lot because of that. Okay, so if you spend a lot of money to develop the electrical vehicles, you are going to develop the batteries, then we can start to use more battery. And of course, anything related to power electronics, because power electronics is here, is everywhere. So every day, power electronics is cheaper, cheaper, and cheaper, okay? So the idea is, let's start to see how that's changed the distribution utilities. That's the main idea here. So now I'm going to talk a little bit about different projects. It's a collaboration between CPFL, the utility at Unicamp, my university, and we call a platform for integration of smart grid. Here I change the name sometimes, depends how much business I want to do. Okay, smart grid, né? This kind of stuff. And in my opinion, this is one of the largest in Latin America right now. Okay, probably I have 1 or 2 slides per project. All the projects are related to that kind of technology. The first one is about the PV farm. This is a finished project, okay? But this was one of the first PV farm in Brazil. Okay? This is installed a high voltage, medium voltage substation. And this is the only project that I have not worked on. This project, I have not active participate in that, okay? The next one, then I'm the PI from the project. And they have around 1 mega of PV in the substation, real-time measurement. I got the results from this. Just go to my lab at Unicamp. Like I told you guys, this is already done. And the idea here is to investigate different technologies. Panel, inverters, sensors, SCADA, and so on. Okay, different kind of technologies there to try to understand how that works, because Brazil has, since starting 2011, we have almost no experience with PV. And investigate the impacts, power quality, efficiency. It's quite important because different panels are here. And in that time, people didn't know how to commercialize this kind of energy. So that's important. How to commercialize that, how we can collaborate with the regulatory aspects when we are doing this kind of research. There's some smart integration and so on. Here probably is the project I'm going to show a few more slides. I think I have 3 or 4. We are just finished this project now. It's similar to the project before, but the idea now is put 1 mega of PV on low voltage network, all in the same place. Okay? We went to the same feeder and put a lot of PV there to simulate in the field a very high penetration of PV. So that's basically the project. Here, the place we put the PV. Here, sub-condo, everybody has PV. Here, for example, is the measurement of one transformer. This is a real measurement of one transformer at I have not told you what is Barão Geraldo. Barão Geraldo is this district where my university is. Okay, it's close to Campinas. And you can see the famous duck curve. This is measurement in our district there. We have around, I think, 4 or 5 transformers with this kind of PV penetration. If you see here, the direct peak and the reverse peak is higher than the direct peak. So we have a very high penetration of PV in this circuit, okay, in this low voltage system. You can see even the energy over 1 month, the energy flows more from the low voltage to the middle voltage side. Okay, so it's a very high PV penetration in the field. And we have everything that happened on these PVs, we have real-time measurement, okay? From the CC side on the panel, from the DC side of the panel, AC side of the panel, the meter in the entrance of the houses. We have installed a lot of power quality meters all over the place. So we have a lot of measurement to discuss. Of course, you have simulation too. Of course, I'm a power system guy, so I have to do some simulation too. And the main aspect of this project is to investigate the main technical impacts of PV on low voltage system. It's important, sometimes people will ask me, okay, but in Germany we have, and blah, blah, blah. The low voltage network in Brazil is quite different. I have been working, for example, with Canadian industry. The low voltage network there and here is another world, okay? Quite different. You cannot think it's the same impact, okay? It's quite different. And the economic is different, and so on. And all the projects we try to develop new markets and service, investigate the integration into the DMS of the utility, investigate regulatory aspects. For example, in the end of this project, CPFL has a new company, the name is Envo. They supply PV. Because the idea is like that, okay, I'm going to have less market in the future because of the PV. I can just complain, or I can be part of the game. That's the idea CPFL decided to do, okay? Here I'm going to show some measurement to show, okay, when we start to put PV, people, oh, everything are going to explode. You'll be a mess. It's not that way. Of course there's a problem, but it's not everything a problem. For example, here we have the harmonic voltage in a transformer, okay? And you can see that here the total harmonic distortion, 95% percentile, and you can see these levels are quite okay. This is one of that transformer I show you guys. A lot of PV, and I could not see any problem about voltage harmonic in the transformer. Here is also voltage harmonic, but in the house, okay? In the customer, you have a lot of PV. What you can see here, the worst time is not even the time I have PV generation. So in this project, you could not find any relationship between the PVs and impact on harmonics, okay? Why that? Because PV generator is an expensive device. If you have money, it's easy to do filtering. okay? The problem is compact lamp lights. Then we don't have enough money to filter the harmonic. But in this kind of, we have similar measurement from cars, electric vehicles, no problem at all. So harmonics, in my opinion, is not a problem in PV case. Here you have voltage imbalance. Of course, it's seen during the generation we have a worse scenario of voltage imbalance. But in this case, we are below the limits. So it's not a big problem. But in some cases, we can have problems. Voltage imbalance sometimes can be a problem. And here's the big problem. This is the voltage somehow. What we have here, over voltage. Okay? This typically is the big problem. You put too much generation of low voltage network. The voltage will be very, very high. Okay? Everything here is measurement. Here, a little more about over voltage. What we have here is the voltage in the middle voltage feeder in the output of the substation, okay? So this is related to the voltage regulator tap. But in general, this varies the university is. So sometimes of the year, we don't have too much load, summer vacation. Then we start to have a lot of load because all the students come back. When that happens, what do people do? Increase the type of the voltage regulator. That's what we have here. They used to do that every year. But what happened? In this plot here, I have how many customers have over voltage problem, customer with PV. And you can see when we change the voltage regulator, we start to have a lot of violation here. So of course, the utilities has to start to change the way they do voltage regulation if they have too many PV. Okay? We talk with the operators. They step down the tap of transformer. You can see improve a little from here to here. But soon after that, they did some load transfer from one feeder to another one. Because of the same case, that feeder starts to have too many students back, blah, 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 blah. What happened? We start to have over voltage problem again. Okay? Everything here is measurement, okay? It's not simulation. So you can see in field, we have over voltage problem if you start to have too many PVs. The next step was, okay, I can do that in a few systems, but how that can impact the entire area of the utility. Then we move to simulation, because I cannot put PV all over the place. CPFL Energy, they have more than 7 million customers. You can do the math, it's impossible to have that many PVs. So we do some Monte Carlo simulation, because many of the aspects, we have no control over the aspects, okay? Who has the PV, where are these customers, what type of PV they have, single phase, two-phase, three-phase PV. Remember, in Brazil, we have three-phase, single-phase, and double-phase customers, installations, and so on. So the idea is we start with all the systems from CPFL, more than 200,000 transformers, and we eliminate transformers from rural areas, transformers who has just a few customers. Because if you have a few customers, you don't have the low voltage system. It's very short. If it's very short, you don't have low voltage high voltage problem. Okay? So doing that, we still have around 8,000 transformers. And we start to do simulation, Monte Carlo simulation, change who has the PV and so on. To take this kind of picture, I have around 8 billion power flow here to have this kind of result. What you can see, the idea is I increase the level, increase the level, increase the level until I have problem. What is the most restrictive aspect? Again, over voltage. Simulation show the same thing you see you have saw in field. Okay? The other problem is overload of the conductors, if the PV goes in the end of the circuit. And another question is unbalance. But you can see over voltage is the main problem here. Okay? If you start to have too many PV, you have to change a little bit the way you do voltage regulate, the way you do reinforcement in the network. That's what very important in this project, okay? Another project is about electrical vehicle. And here the idea was similar, but much less customer involved because electrical vehicles is much more expensive than PV, okay? But the idea was to install some public stations. We have normal, semi-fast, fast charging stations. We have some home charge station. We have a few electrical vehicles, and everything here, we have monitoring real time, send the information for Unicamp, and you do a lot of analysis, okay? And here is something similar. You have to build the behavior models. That's quite important. We don't know, because people can say, okay, the electrical vehicle is the size of the electrical vehicle in power is not that different from electric shower you have in Brazil. That's true. But I know how the showers behave. I know when people go to the shower. I don't know how people are going to use the electrical vehicle. I'm not saying this, oh, it's the end of the world. But I have to know. If I don't know that, how can I know the load behavior? I need to learn this kind of stuff. Okay? Again, investigate the main impacts. Of course, here, one of the main impacts is undervoltage. Okay? Because typically people go to charge the electrical car during the peak time. Someone can say for me, okay, but the peak time in Brazil during the summer now is the mid of the day. Is the mid of the day for the transmission system. If you go to the residential feeders, the peak is in the end of the day because people are in the work during the day. Okay? Of course, you have some overloads, but it's not the end of the world. Again, develop new servers, market, blah, blah, blah. It contributes to regulatory aspects. This was another project. Another project we just started. Here we don't have measurement yet because we are installing the batteries right now. Okay? Here, the project is about to develop different applications for storage in distribution system and different kind of application. So one of the systems we are going to install is this size, and we are going to install in this substation. This is a substation that feeds Barão Geraldo and Unicamp. Okay? And we are going to start, okay, what this kind of technology, this size, installing this place can do for the system. The other application is a medium-sized solution. Okay, here the idea is to install some batteries in a middle voltage, low voltage transformers. We are going to install this battery in some place we have a lot of PV on the low voltage side, and we have a lot of electrical vehicles on the low voltage side, and see how can I use the battery to reduce the impact from PV and electrical vehicles. Okay. And finally, you go inside the house of the customers. Here, some people, they have PV. We are going to install some batteries there, and the idea, okay, in the middle of the day, please do not inject power in my network. I can have over voltage problem. Do that in the end of the day because I have under voltage problem. This kind of stuff. But this project, we don't have too many results so far. The main problem with this project, to be quite honest so far, is how to get this technology. There are not too many trustable suppliers outside to give you this kind of technology. Okay, it's not easy to go to the market, oh, I want to buy that. A lot of people go for you and say, okay, I have, but it's going to explode, okay? So you have to be careful about that. And the project is about developing new applications, new services, and so on, similar to the other ones. Here we have a few, because I don't have so many measurement results, I have a few papers. You can read the papers, okay? This is another project. This project I did in the past in Canada, and we are doing something similar now in Brazil. And the idea here is, how can I use the smart meter or some modified smart meter? How can I use the voltage and current information in the entrance of the house to do the bill breakdown, to give people the information? How do you use the energy? Okay? That much is refrigerator, that much is microwaves, and so on. Because right now, the relationship between the utility and the customer is not good. Because the utility just send the bill, okay? Give him $200. and so on. But if I can give more information for this kind of customer, I can have a better relationship with this kind of customer. And if as a government, I decide to do some efficiency program, if I know how we use the energy, I can be much more effective. If you think this is the way cell phone works, this is the way internet works, and so on. So the idea is try to use this. Of course, there's a lot of math here. And take this kind of power measurement and say how you use this, okay? During this project, some of the project, this example, we have some startup company. He's a company to build meters. And they have, if you see here, a different CPU, and this CPU can do a lot of local math to help us in this kind of solution, okay? This is another project, the sustainable campus. We are going to do, I'm going to start to be a little bit faster because I have only 5 minutes. The lady here is, okay. But it's similar. Everything I've shown for you so far is outside the Unicamp. Then we start to go inside the Unicamp. We are going to start this kind of technology inside the Unicamp. So there's not too much to say here. Okay, here is, we're going to put a lot of PV, blah, 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 sensor, meters inside the campus. Oh. Here's another project that starts now. Is about we are going to have an electrical bus inside the campus. And here's something interesting. We are going to do this kind of charge station, a net zero energy charge station. The idea is I have PV, I have battery, and over the year, I don't need to use any energy from the system to charge the bus, and the bus are going to be used inside the universe, and so other aspects, okay? I'm going to not talk about this project, but this starts right now. One of the problems of the microgeneration PV is overvoltage. So we start a project, how can we improve that? Another problem is the power factor of quite crazy. So we have start a project is about how to do volt var control, compensation, in distribution system if you have too many PVs. Another project is about technical loss. I'm not going to talk too much about this project. Two important things maybe. In both projects we have some startups here, okay? Another startup here. So I'm going to show how these projects are in the same place. Here is Barão Geraldo, here is Unicamp. Here's a technological park, so this substation is quite important. This is Barão Geraldo substation. This is a transmission line, okay? Here is a middle voltage feeder and a low voltage feeder. All this project, everything is in the same place, okay? You have PV, you have electrical vehicles, you have meters, you have battery, you have everything in the same place. That's the idea. And out this project, they send a lot of information to ourselves at Unicamp. It's more than 2 billion measurements per year we have to deal with there. So it's kind of big data, okay? So this project, we are learning a lot. The next project should start this year. Oh, we are still in 2018. 2019, we are going to start another project about microgrids. Then we are going to have different microgrids. A microgrid inside the lab. Here can do a lot of things, nobody are going to die. Then some microgrids outside the lab and see what we can learn from this, okay? So, some final comments. I'm okay, right? Some final comments. Why a live lab? I'm not going to say here for you guys, okay, it is the only way to do research. Everyone has your way to do research. But here are some points I decided to go for a living lab. Technological research should go outside the university walls. I need to understand how people are going to deal with the kind of development I do, because they think very, very different for us. For example, when we start to offer the PV for the project, most people, no thanks. No, but it's very expensive. CPFL pay more than 50% of the, no. I think something is wrong. Why you want to put a PV in my, no. So it's not that easy when you go outside the university, but it's quite important because you learn a lot of things. Because you are educated, you are electrical engineer. We have a lot of interest in that. But most of the people, they just don't care. So it's important to have this kind of background, feedback, sorry. Technical development must be in accordance with economic, regulatory, and market. So most of the research we do, we have something related to economic, we have something related to market, we have something related to regulatory. Of course, my background is technical. Okay, V equals Z, Y. But I need to know more than that if I want to make some technological impacts, okay? This is quite important in my opinion. If you do a very sophisticated lab inside the university, mainly in Brazil, it's not easy to keep that, to maintain this lab. If I go outside, I have no problem, zero cost. CPFL take care. Okay, I ask, okay, install that. Now, take off, and so on. Even the meters. I want to put that power quality meter that place. Of course, sometimes, this is a real history, you go to the transformer, you ask to put some power quality meter there, there's nothing there. And you took a few poles down, oh, the meter is there. And you ask for the technician, why the meter is there? Oh, here, was not good, you see? A little bit bust there. No, oh, much better, okay? That's real life, okay? But it's quite important. I have almost zero cost for the, I'm finished, this is my last slide, okay? In my opinion, we have more possibility of successful startup companies. Some of that company I show for you guys right now, they are not more startup company. Now they are inside the scale-up program from CPFL, okay? But, since you have a lot of students here, not to be misunderstood. Although technical research and product development are important, academic research are vital, okay? Theses, dissertations, papers, they are. I'm not going to say, okay, just go for the product, just go for, no. You need to have the academic research too. You need to have all this stuff, and then you can maybe have a little more than that, because you are inside the universe. If you want to know only about the product, start a new company. Don't stay inside the universe, okay? Thank you.
Thank you so much, Professor Valmir, to share with us these results.
You see, very technological, my watch.
Yeah. To share with us these results and the acquired experience of this kind of quite interesting research projects. So we have time for questions.
Please don't ask me why I don't use a cell phone. Because I'm not going to be polite. I'm going, if I have a cell phone, people call you. People send messages for you. That's crazy. Okay.
Thank you for the presentation. It's very interesting to see that people is working a lot using real measurements. It's a curiosity that I have. I don't know if you will have the answer, but when you are working with high penetration levels of PV, did you notice that protection engineers are concerned about the protection settings and distribution feeders?
Okay. We did a lot of studies from protection. In the rooftop project, since all the PV, they are on the low voltage network, and they have a transformer, a big impedance, they have no impact on the protection on the medium voltage network. And we did some simulation like, okay, 50% of population have PV. The PV is able to keep the current, what's not true. And even so, the only thing I found in one feeder from CPFL, sometimes a recloser operate for a background fault. The only thing I saw was that. So the impact is not that huge. But if you start to have synchronous generators, then it's another history.
More one question? No.
Congratulations, Valmir, Homer, for this.
Yes. When I'm in Canada or USA, I don't say Valmir, I say Walmer, because it's impossible for them to say Valmir. And then the one Canadian guy told me something like that. Say Walmer, like Walmart. That's it. Everybody knows my name. Okay.
Okay, congratulations for a very nice and impressive presentation. My question is regarding you said about 8 million load flows, something roughly. Billions, yeah, okay.
We have a very, very powerful server there bought by CPFL now.
Oh, okay. But my question is regarding the overvoltage problem. If you, in those load flows, you are using, you are considering that you are generating in one per unit power factor, or if you are using the inverters to control the voltage as well.
Okay. Nowadays in Brazil, the inverter, they cannot control the voltage. Okay. All the inverters operate in unit power factor. Okay. But even if you can, it's not that effective. Why you have a power over voltage? Because there is a math formula is active power times resistance. Okay, this increases the voltage. The other part of this equation is reactive power times X. But if you go to low voltage system, R is 2, 3, 4 times higher than X. Even if you start to consume a lot of reactive power, you are not going to solve the problem. In low voltage network, okay? Middle voltage, high voltage is another. In low voltage network, you are not going to solve the problem that easy. The best way to solve the problem in low voltage network is change the wire, okay? Is to do some split the system and so on. Because reactive power is not that effective in low voltage system. Middle voltage is okay, in high voltage very, very okay, but in low voltage system is not that good.
Okay, as a follow-up question, still regarding overvoltage, how much is in per unit the voltage at the substation in that feeder? Because sometimes some of the utilities use quite high.
Unicamp uses, CPFL is 1.035. They don't have voltage line drop compensation. That's not CPFL Paulista, okay, one of the utility. They don't use line drop compensation on the substation regulator. It's all day long 1.035 pu. Most of the substation something like that at CPFL.
Okay, let me just share.
The results will be different if you go to different utilities,
of
course.
My experience with another utility that they use 1.05.
I was waiting for that because I have some meeting because of the results from Glauco. Okay, go on.
And they start with 1.05.
Oh no, but that's
and
not
we argue with them that okay, we cannot use 1.05 anymore because otherwise you're gonna have a high voltage in the feeder. And then they said, no, we cannot do this because if we decrease the voltage, that feeder, that transformer, sometimes feeds more than one feeder, and the neighborhood feeder could face low voltage.
Yes.
So I think in the future, if the penetration will increase, maybe you're gonna have a transformer for each feeder.
Okay.
Then you can you could control the voltage differently for different levels of penetration.
The project is just finished.
Yeah.
Since you are in the low voltage, the idea was, okay, if you have a problem, go for a new wire, blah, 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 reinforcement. The project we start right now is about to use different technology to solve the problem. Okay, how to coordinate the voltage regulated substation and the line regulators. You have to change it. It's not the same way. We are going to, we have already this one low voltage system. We have a voltage regulator for low voltage system. We installed this like 1 month ago. I don't have the results right now, but we have the voltage regulator on the low voltage system. I'm not going to say this is the good one, because in my opinion, it's too many voltage regulators to be put there, but we have different solutions. One thing we did already there, if you change a little bit the regulation, the coordination between the substation and the line regulator, we have some improvement. But the thing that helps a lot, if you start to have different voltage reference in different time of the day. This helps a lot. But it's not 100% solution.
Thank you, Vomir. Very interesting presentation, very impressive workbench you have. And I'm going to make sort of a classical question, but then it's interesting that you have the experience to be able to answer it from your experience. How you're gathering information from the consumers in Unicamp, at the servers at Unicamp. How do you deal with sensitive information about consumer behavior?
Many no-disclosure agreement. I have a lot of information there. I have even if people pay the bills or not pay the bills. And I have access to the SCADA from CPFL from inside the Unicamp right now. So we start to have a very, very close relationship, but it's not easy. People from IT, they hate me, okay? Because every month I go there, oh, wait, what, this more, and this more, and this more. Right now, most of the information from CPFL, even the SCADA, I can access that from my computer inside my office at Unicamp. This is the kind of relationship we have now with CPFL. But it was not easy to get there.
Okay. Thank you.
I have to be... If they pay well for me, that's okay. If they stop to pay me well, I'm going to blackmail a lot of people, okay?
So I have no doubt this is a quite interesting discussion, but we have to stop here, and I invite you all for a break with a coffee break there. So thank you very much.